Here we're going to look at the topic of expected value, which tells us what's going to happen over the long term. Not what's going to happen in a single trial, but what we expect to happen over many trials. Expected value is done with a formula, and we'll take a look at that first. When we look at expected value, we're looking at situations that have multiple results, and each of those results has a probability associated with it. The formula reflects that for us. And as we look at this, we've got result number 1 and the probability of that result. We multiply those together. We've got result number 2, the probability of result number 2, and those are multiplied together. And then we might have a whole bunch of different results, but eventually we get down to the very last result. We'll call that result n, because we don't know how many we're going to have. And that result is going to have a probability associated with it, and we multiply those together. Let's take a look at how this works using a spinner as an example. So we look at this spinner as a game where we're going to spin the pointer. It's going to land in one of these regions, and whatever region it lands in tells us what happens. We could lose $2, we could lose $1, or we could win $4. Those are our results. So result number 1 is that we could lose $2. Result number 2 is that we could lose $1. And result number 3 is that we could win $4. Now each of these results is going to have a probability associated with it. So let's look at those. The probability of result number 1. As I look at my spinner, that's half of the spinner, so that's going to happen half of the time. When I look at result number 2, that has a probability associated with it. I'm going to lose $1 1/4 of the time. And then when I look at result number 3, I'm going to win $4 1/4 of the time. So now I know all my results, I know all the probabilities that go with them, so I'm ready to find the expected value. Expected value equals the probability of result number 1 multiplied by result number 1. We add that to the probability of result number 2 multiplied by result number 2. We add that to the probability of result number 3 multiplied by result number 3. If I had more results, I'd just keep going until I got to the very last one. This is all I have, so this is as far as I need to go. Now I can simplify this. So my expected value is going to be, let's see, a half times -2. That'll be -2/2. 1/4 times -1 will be -1/4. And then 1/4 times +4 will be 4/4. In order to add these, I'm going to need a common denominator. So that'll be 4. And so I've got -4/4 plus -1/4 plus +4/4. And when I add all those together, I get -1/4. So my expected value here is -1/4. If I divide those to put this in decimal form, I'm going to get -0.25. And what this means is, over the long term, I expect to lose 25 cents per play. Notice, I can't lose 25 cents on a single individual spin. That's not one of the outcomes. What this means is over the long term, if I were to play this game 100 times, I expect to lose 25 cents per play. And that's how expected value works. Let's look at one other situation. A raffle charges $5 per ticket, and 100 tickets will be sold. One first prize of $200 and 3 second prizes of $50 will be awarded. What is the expected value of buying a ticket for this raffle? One thing that's really important to notice here that's different from our spinner. In the spinner, we just did a spin, whatever the result was, that's what happened. Here in a raffle, this is a special situation where we pay $5 per ticket and we don't get that $5 back. So if we win, our winnings here is not going to be $200, it's going to be $195. If we were to win a second prize, our winning isn't $50, it's $45, because we've paid that $5 and they don't give us that back if we happen to be a winner. Let's look at the results and the probabilities that go with them, and then we'll find the expected value. So here, result number 1 is I could be the first prize winner. Remember, the first prize is $200, but I don't get my $5 back on top of that. So if I happen to be the first prize winner, I win $195. I come out ahead by that much. Result number 2, I could be one of the second prize winners. I get $50. Great, I didn't really win 50 because I paid $5 for the ticket, and they don't give me that $5 back on top of my winnings. So if that happens, I'm a $45 winner. And then result number 3 that could happen is that I could just lose. I could not be a winner at all, and I could lose my $5. So those are the 3 results that could possibly happen. Now let's look at the probabilities that go with those. The probability of result number 1. Well, let's see. They are selling 100 tickets, so there's 100 outcomes. And there's only one first prize winner. So the probability that I win that is 1 out of 100. The probability of result number 2. Again, there's 100 tickets. And the probability that I'm a second prize winner, well, there's 3 of those. So the probability that I'm a second prize winner is 3 out of 100. Let me clean that 3 up a little bit there. 3 out of 100. And then finally, the probability of result number 3, there are 100 tickets, and let's see, there's going to be 1 first prize winner, there's going to be 3 second prize winners, so that means there's 4 winners overall. We've seen that, which means 96 people aren't going to win at all. There are going to be 96 people, or 96 tickets that are losers, and so the probability of that happening is 96 out of 100. Now I have all my results, I have all my probabilities, I'm ready to find the expected value. Let's go ahead and do that. My expected value is going to be probability number 1 multiplied by result number 1 added to probability number 2 multiplied by result number 2 added to probability number 3 multiplied by result number 3. We'll carry this over on the next page. There's where we're at, working with our formula. Now we need to multiply, and I'll have 195 over 100 plus, let's see, 45 times 3, 135 over 100, and then 96 times 5, negative 5, is negative 480 over 100. Kind of nice, we already have our common denominator, so we can go ahead and add these up, and I get negative 150 over 100, which if we write that as a decimal by division, we'll have negative 1.50, which means the expected value of buying a ticket for this raffle is negative $1.50. I would expect to lose $1.50 over the long term. Please keep in mind that with raffles, you're paying your money up front and you're not going to get it back. So what that does is that changes the amount of a win if you are going to be one of the winners. So figure that into your formula when you're working on expected value of problems that are raffles or anything where you pay your money up front and then you don't get that back on top of the payout.